Hello and welcome back to Summer Work Help for Calc 1. In this video, we're going to be taking a look at question number 21. So 21 says, write the following expression, 3 log of x base 2 plus log of 5 base 2 minus the log of y minus 1 base 2 as a single logarithm. Okay. So this is kind of the opposite of question 20, or maybe inverse of 20. Question 20, the direction said expand it as much as possible. Well, now in 21, the logarithm has been expanded, but now we want to try to condense it as much as possible. So for any of the laws of logarithms that we used in 20, in 21, we're going to kind of go in the opposite direction, which I guess is like from right to left. So we're going to use these properties of logarithms again. But we're going to be kind of going in this direction now. So, and again, this is going to be a relatively short video. Yeah, let's just go ahead and get it done. So the first thing that I noticed with this problem is that in order for us to condense the logarithms into like a single logarithm, first of all, any coefficients in the front, we need to sort of apply this rule, okay? We need to apply that rule, again, going from right to left, so going in this direction. Because I can't really combine the logarithms if they've got these different coefficients on them, or maybe I can, but I just don't want to. So, I want to deal with the fact that there's a 3 in front of the first term. I want to deal with that first. There's no coefficient here, there's no coefficient here, or rather, that is to say the coefficient is 1, so I don't care about it. But what I want to do with that first term, that 3 log of x base 2, I want to use the power rule to move that 3 to like inside the logarithm on the x. So what's going to happen is I'm going to take that 3 and I'm going to move it right there. So my first term becomes log of x cubed base 2. So, you know, if you don't see that, maybe pause the video for a second. We are applying the power rule, which I highlighted. We're going from right to left. And what I'm doing is I'm taking the number in front of the logarithm, the coefficient, and I'm moving it sort of back, maybe not back, but I'm moving it to on the argument that's going into the logarithm, which is x, and I'm making it x cubed. So I'm moving the 3 back into being an exponent. Then the rest of this, I'm just going to rewrite. Okay. Now I'm in a pretty good spot to condense this into a single logarithm. Before I do, however, I do just want to point out something about this term here, the last term, right? And because I've seen students get tripped up by this before. So all of the rules that we have for logarithms, they're over here. Notice that, and I'll erase the extra stuff here, so we don't need that, don't need that. Yeah, this thing does not like erasing highlighting. I don't know why. It makes it kind of challenging. There we go. All right. So notice that with the rules for logarithms, we have a product of a single logarithm, and that turns into multiple logarithms of each factor. We have a quotient that's a single logarithm, and that turns into the difference of the numerator and denominator. And I'll pause there. Sometimes students see something like this. They see the log of, and then they see a difference, and they think that that can be like broken up somehow because there's, you know, we broke up a product, we broke up a quotient. But the thing is, if the logarithm itself is a difference, which is what this is, it's y minus 1. Well, that's not what we have over here. the time that we have a single logarithm, well, that's the quotient. But then the only time we have a difference is right here. But that's not, it's not like, this is different from the log base A of x minus y, right? That is not the same thing. So when you have the log of a difference, as of right now, there's not really a whole lot you can do about that, okay? So just in case you were tripped up by that, we are not going to really be messing with that y minus 1 because that's a difference, and that's just not how the properties of logarithms work. The single logarithm has to be either of a product or a quotient, and y minus 1 is certainly not a product, and it's not a quotient either. So what we have here, and in order to use these rules, you have to have the same base, right? So notice it's log base 2, log base 2, log base 2. So we're allowed to sort of combine these things. So what I have here is I have the log of, and I'm not going to say base 2 every single time because it's just base 2, and well, that's just fine. So we're going to skip the base 2. So I have the log of x cubed plus the log of 5. So notice over here, right here, when you have the log of something plus the log of something else, that is the log of the two of those things combined. So that's exactly what I want right here. So I can combine the first two, log base 2, and I'm gonna have x cubed times 5. All right, x cubed times 5, and just to save myself a step, the convention is that the 5 would be sort of the first leading term. So I'm going to put the 5 out front, just like that. So I have multiplied the x cubed times the 5, and then I moved 5 to the front because that's how it normally looks. And again, I'm able to do that because I have a sum. I have a log of something plus a log of something else, and they have the same base of 2. So that means I can combine them into a product, because that's what the product rule says, minus the log of y minus 1, base 2. Okay. So now I have the log of something, 5x cubed, minus the log of something else, y minus 1. They're being subtracted. So I have a difference of logarithms. Same base, base of 2. That means I can combine these into a single logarithm, base 2. Because I am subtracting them, I'm subtracting the two logarithms, it means that when I combine it into a single logarithm, it's going to be a quotient, because that's what the quotient rule says. So the 5x cubed, that's my numerator. And then I'm dividing by the second logarithm, which is y minus 1, close parentheses. And that, as we were instructed to do, is a single logarithm. It's the logarithm of 5x cubed divided by y minus 1 base 2. And that is about as much as I can do with that question. So again, relatively straightforward application of the laws of logarithms, the properties of logarithms. And again, don't forget what I said. Sometimes students, they see this logarithm of a difference or the logarithm of a sum, right? So I'm going to do the same thing up here. This is not saying the log of x plus y. Okay, in order to use the product rule, you need to have the sum of two separate logarithms. Okay, in order to use the quotient rule, you need to have the difference of two separate logarithms. You can't just have the log of a difference or the log of a sum, right? So just be aware of that, right? And an easy mistake to make for sure, one that I've made. So you want to just be aware of that when you're working with these different properties of logarithms. So final answer for 21, log of 5x cubed divided by y minus 1 base